Good morning friends. After the deriving the equation of stationary wave, right? We derive the equation of the stationary wave y is equal to 2a sin kx into cos omega t. We also seen that in stationary wave, the stationary wave loses the property of propagation of a wave. That means the pattern in the medium is constant, not moving. It means the stationary. But the different point of the string or the medium perform the simple harmonic motion with the different amplitude. The amplitude of the sum of the points is 0, while the amplitude of oscillation of sum of the point is maximum. On the base of this, we are going to define the nodes and antinodes, and also we want to derive the equation of the nodes and antinodes. For that purpose, the question is that write the equation of a stationary wave and obtain equation of node and antinodes by defining them. This question is most important. This question is most important. Now first we have to write down the equation of the stationary wave. The equation of a stationary wave is y at point x and t is equal to 2a sin kx into cos omega t. That is the equation 1. Here the cos omega t term represent the each point of the string from the simple harmonic motion. Here cos omega t represent all the points of a string perform simple harmonic motion, and its amplitude is two a sin kx. Now, for different value of the x, the amplitude of different point of the strings are different. For different value of x, the different point of the string have different amplitude. Again, the equation of the stationary wave is y xt is equal to 2a sin kx. This term cos omega t represents all the points of the string perform the simple harmonic motion. That means they oscillate about their mean position with amplitude represented by the equation 2a sin kx. Right? For different value of the x in equation of the amplitude, we obtain the different point of the string having the different amplitude. First we do the diagram of the stationary wave like this way. Here the stationary wave is this. Here the string tied at the both ends. Here the wave is, stationary wave is like this way. and the other M is propagate in opposite direction with the same frequency and same wavelength superposed on each other. So as a result, the stationary pattern is formed. Stationary pattern is formed. So here the length of a string is x is equal to 0, then say x is equal to x. The point at which the amplitude is 0, these points are known as the node points. These points are known as the node points. N, there is also that. Now the definition of the node points is that first the node points or the nodes. The point of the string where the amplitude becomes 0 is known as the node points. The points of the string where the amplitude is 0. Are known as node points. Are known as nodes. Yeah. For node, the amplitude is 0, that means that 2a sine kx is equal to 0. Therefore, 2a sine kx is equal to 0. Therefore, sine kx is equal to 0. Now, 0 of the sine is obtained at n pi. Therefore, kx is equal to n pi. Kx is n pi. Where the n is equal to 0, 1, 2, and so on. But k is also 2 pi upon lambda. Therefore, 2 pi upon lambda into x is equal to n pi. Pi cancel. Therefore, x is equal to n lambda by 2. X is equal to n lambda by 2, where the value of n is equal to 0, 1, 2, and so on. And we substitute the different value of n in this. So we obtain the different point of the string where the amplitude becomes the 0. Therefore, from x is equal to 0, by substituting the x is equal to 0, n is equal to 0. So first node point obtained at 0. Second, n is equal to 1. Second is obtained lambda by 2. N is equal to 2 lambda. And so on. N lambda by 2 from end of a point like this way, from end of a string right, and x is equal to 0, lambda by 2, lambda, and so on. Distance is first, second, and so on. Nodes are obtained. It is denoted by capital N, denoted by capital. So that is the equation of the node. Just we discussed it that the 2a sine kx is represent the amplitude of the different points of the string, and the amplitude of different points of the string is also different. Therefore, the points of the string where the amplitude becomes 0 are known as the nodes. For nodes, 2a sine kx must be 0. Therefore, sin kx is equal to 0. Right? For which value of the sine we obtain the 0 value for n pi. Therefore, kx is equal to n pi, where the n is equal to 0, 1, 2, and so on. So, and we also know that where vector k is equal to 2 pi upon lambda. Substitute here 2 pi upon lambda into x is equal to n pi. Therefore, x is equal to n lambda by 2, where the n is equal to 0, 1, 2, and so on. Thus, from the end of the string at x is equal to 0, lambda by 2, lambda and so on, distance, the first, second, and so on, nodes are obtained. And it is denoted by the distance between the two consecutive nodes is lambda by 2. The distance between two consecutive nodes is lambda by 2. Because there is this distance is known as the lambda. Here we obtain the node points at here. Therefore, between the two consecutive nodes, distance is lambda by 2. So that is the lambda by 2. That is also lambda by 2. Now the antinodes. The point on the string where the amplitude is maximum are known as antinodes. The points on a string where amplitude is maximum are called are known as antinodes. It is denoted by capital A. Now in the figure, these are the points at where the amplitude becomes the maximum. This point. So these are the amplitude. These are the antinodes, where the amplitude becomes the maximum. Right? Therefore, mode of sin kx. Therefore, mode of sin kx, maximum value of the sine is 1. Maximum value of the sine is 1. Therefore, we can write kx is equal to n plus 1 by 2 pi. N plus 1 by 2 pi, where the n is equal to 0, 1, 2, and so on. 1, 2, and so on. And also we know that k is equal to 2 pi upon lambda. Therefore, equation 2 pi upon lambda into x is equal to n plus 1 by 2 into pi. Pi cancel. Therefore, equation of antinode is x is equal to n plus 1 by 2 into lambda by 2. That is the equation of antinode, where also n is equal to 0, 1, 2, 3, and so on. Thus, from n of a string and distances x is equal to, first we substitute the n is equal to 0. We obtain lambda by 4. n is equal to 2. That is the 3 lambda by 4. N is equal to 3, 5 lambda by 4. And so on. N plus 1 pi, 2 into lambda by 2. Distance, first, second, and so on. Antinodes are obtained. Antinodes are right. So as we substitute the different value of n in this equation, so from the n of the string x is equal to 0, first is obtained at lambda by 4, second is 3 lambda by 4, next is 5 lambda by 4. This way, nth antinodes is obtained at n plus 1 by 2 into lambda by 2 distance. That means the 2n plus 1 lambda by 4 distance. Right? The distance between two consecutive antinodes is how much distance? So there is the antinode. This distance is also lambda by 2. There is also lambda by 2. Is lambda by 2. But the distance between the antinode and node, or the node and antinode, consecutive antinodes and nodes, or consecutive nodes and antinodes, is half of this. That means the lambda by 4. The distance between consecutive nodes and antinodes is lambda by they are the same. Again, there is the most important question. We start to answer this question. Question is that write the equation of a stationary wave and obtain the equation of nodes and antinodes by defining them. First, the equation of the stationary wave is yxt is equal to 2a sin kx cos omega t. Here the cos omega t terms represents all the points of a string perform the simple harmonic motion, and its amplitude is represented by 2a sin kx term. From this equation, A is substituted the different value of x. We obtain the different point of the string having the different amplitude. Thus, for the different value of x, the different points of the string have the different amplitude. Right? Okay. Now, here is the diagram of the stationary wave and position of the nodes and antinodes. Okay. Now, what is the node? The points on the string where the amplitude is 0 are known as the nodes. It is denoted by capital N. To obtain the equation of the node, 2a sin kx is equal to 0. 2a sin kx is equal to 0. Therefore, sin kx is equal to 0. Therefore, kx is equal to n pi, where the value of n is 0, 1, 2, and so on. But k is equal to 2 pi upon lambda. Therefore, 2 pi upon lambda into x is equal to n pi. Pi cancel. Therefore, x is equal to n lambda by 2. For different value of n, we obtain the position of nodes, where the n is equal to 0, 1, 2, 3, and so on. From n of a string at x is equal to 0, first node is obtained, second is lambda by 2, third is lambda, next is 3 lambda by 2. Distance, first, second, and so on, nodes are obtained. It is denoted by n. The distance between the two consecutive nodes is lambda by 2. Right? Okay. Now what is the antinodes? First the definition. The points on the string where the amplitude is maximum are known as the antinodes. It is denoted by capital A. In figure, this A represents the antinode. This point of the string where the amplitude of the oscillation is maximum. Okay. In equation of the amplitude is 2A sine kx. Amplitude depends on the sine function. For the sine value becomes the maximum, therefore the amplitude is maximum. Therefore sine kx is equal to maximum value 1. Therefore kx is equal to n plus 1 by 2 into pi, where the n is equal to 0, 1, 2. Now, and also k is equal to 2 pi upon lambda, substitute here, 2 pi upon lambda into x is equal to n plus 1 by 2 into pi, pi cancel, so we obtain x is equal to n plus 1 by 2 into lambda by 2, is the equation of antinodes. That is the second equation of nodes, and that is the third equation, represent the equation of antinodes. Thus, from the end of a string at x is equal to, as we substitute the different value of n in this equation, we obtain the position of antinodes on the string. For n is equal to 0, first antinodes obtained at lambda by 4 distance. N is equal to 1, second antinodes is obtained at 3 lambda by 4. N is equal to 2, third antinodes is obtained at 5 lambda by 4. Thus, from the end of the string at x is equal to lambda by 4, 3 lambda by 4, 5 lambda by 4, and so on, n plus 1 by 2 into lambda by 2 distance, the first, second, and so on, antinodes are obtained. The distance between the two consecutive antinodes is lambda by 2. The same way, node. Here the antinode lambda by 2, again antinode lambda by 2. And the distance between the consecutive nodes and antinodes is the half of this, that means the lambda by 4. Again, antinode to the nodes lambda by 4. So keep in mind, that is the most important thing for the one mark objective question. The distance between the two consecutive nodes or the antinodes is always lambda by 2. While the distance between the nodes and antinodes or antinodes and nodes is lambda by 4. Okay?